Swayam Prabha. Digital India. Educated India.
Good morning. Welcome back to lecture number 10, part 1 on the topic compressor. This is the first topic in the module number 2, refrigeration cold chain management. Primarily in module number 2, we'll be studying about the major components of a vapor compression refrigeration system. So there are 4 major components of a vapor compression refrigeration system: compressor, condenser, expansion device, and evaporator. So we'll be studying about the construction, working principle, comparison of different types, and we'll be solving few numerical questions. So in this lecture, we'll start with the first portion, that is part 1. Part 2 also I will be continuing with the compressor. So let us see the introduction. If we take the compressor, compressor is the heart of the vapor compression refrigeration system. It is a very, very important component. It increases the pressure of the refrigerant from low pressure, that is evaporator pressure, condenser pressure, which is high pressure. If the pressure of the refrigerant is not raised from evaporator to condenser, then there is no possibility of condensation to take place. For the condensation to take place, there should be the condensation, the process of phase change from vapor to liquid. During the process, heat is rejected. That is rejected to the heat sink. Normally, in smaller capacity systems, air-cooled condensers are preferred. So, as I said, the compressor increases the pressure of the refrigerant from low pressure to high pressure. The capacity of a refrigeration system, it depends upon the compressor capacity. It depends upon the compressor capacity. Let us see the classification based on the arrangement of compressor motor. Based on the arrangement of compressor motor, it is classified into 3 types: open type, semi-hermetic, and hermetic. This is the photograph of the open type compressor. Given the reference I have taken from the Wikipedia. So here, as the name indicates, the compressor motor is open. I mean, it is exposed to the environment. It is exposed to the environment. There is no casing or like a housing arrangement, unlike in a hermetic type of compressor. This is the picture of the semi-hermetic. So here the compressor and the motor are sealed, but it is not welded. It is not welded. They are connected maybe through the help of screws and bolts, etc. So if you want to open the compressor, it is quite possible during repairing or any maintenance work. Hermetic, it is completely sealed. The word hermetic refers to like it is like airtight sealed. So neither air can get into the system nor can leave from the system. It is completely welded. The casing is welded, and in case if you want to do some maintenance, it is not possible in this. So let us make a comparison of the 3 types of compressors. First one is open type. Second one is semi-hermetic. And third one is hermetic. Third one is hermetic. So if we compare the cost wise, since the open type does not have a casing, it is exposed to the environment. Obviously, compared to semi-hermetic and hermetic, the cost will be less. Low cost compared to other two types. And if we see the maintenance or serviceability, it can be serviced easily, easy maintenance, easy to repair and maintain and maintain. That is, servicing is easily accessible. That is easy access. Easy. Here it is somewhat difficult, but it is possible. Repair and maintenance maintenance is difficult but possible. The screws or the bolts can be removed, then we need to do the repairing or the servicing work. In case of hermetic, once the compressor gets damaged or if there is any technical problem in the compressor, then it cannot be serviced. It cannot be serviced. Cannot be serviced or repaired. It is like use and throw. As long as the compressor is working properly, fine. Once if any major technical issues are there, then the compressor need to be replaced. Compressor need to be replaced by a new one. And this is exposed to environment. Because of this, there are chances of the dust particles, dirt particles from the air getting into the system. And this is not exposed to environment. Not exposed to environment. Of course, this is also not exposed to environment. Not exposed to environment. In open type of compressor, there are chances of refrigerant leakage. Refrigerant leakage. Refrigerant leakage. So in the other two types, the refrigerant leakage is not there. Unless there is a major fault in the system. In this one, there will not be any leakage of the refrigerant. When we compare these compressors from the viewpoint of applications, normally hermetic compressors are used for smaller capacity applications, where applications which require smaller capacity system, like household refrigerator, split AC, window air conditioners, etc. So this it is used for small capacity application. Whereas open type and semi hermetic are used for large capacity This is also used for large capacity application. So here when we say smaller capacity, as I mentioned, it is household refrigerator, split AC, window AC, etc. I mean, in a small type of grocery stores, etc. Also, this can be used. When it compared to open semi-hermetic type, it is used for, industrial and commercial applications. Industrial or commercial applications. Industrial and commercial, such as like it is used for in marine, rail, marine, rail. Then you have supermarket, etc. Open type compressors are used also for large capacity applications which require large capacity, such as cold storage, warehouse, etc. That is, this is also mainly used in industrial and commercial applications. That is, industrial, in many industrial or commercial applications. So this is about the overview of the comparison of open, semi-hermetic and hermetic type. So let us move to the next classification. This is classification, it is based on the working principle. So first classification is based on the arrangement or the construction of compressor motor, According to the working principle, it is broadly classified into two categories. One is positive displacement and another one is rotodynamic. Under positive displacement, we have got reciprocating, rotary. We have got reciprocating and rotary type. In rotary, we have got scroll and screw type. Under the rotodynamic classification, we have got axial type of compressor and centrifugal type of compressor. Let us see what do you mean by a positive displacement compressor. See, when in a positive displacement compressor, it refers to a fixed volume of refrigerant, that is the gas, fixed volume of gas is trapped inside the cylinder in case of a reciprocating compressor. So compression is achieved by trapping the refrigerant vapor in an enclosed space. Fixed amount of refrigerant is taken inside, and this type of compressor has high wear and tear, vibration is high, the noise level is high. One such example of positive displacement type of compressor is reciprocating compressor, which has got a piston cylinder arrangement. So there is a suction valve and a discharge valve. This is the piston, this is the cylinder, and a connecting rod. It reciprocates inside the cylinder. It reciprocates inside this one. The connecting piston reciprocates inside the cylinder, which is one end of the piston is connected to the connecting. So through the suction valve, the refrigerant enters the cylinder. So as the piston moves from top dead center to bottom dead center, as it moves, the volume increases. So the refrigerant is trapped inside, and normally in the actual case, this is the construction of a actual type of reciprocating compressor, not an ideal condition. So always there is some clearance volume which is provided at the top of the cylinder. So when we have the cylinder volume, maximum the piston can travel to the top up to the point of clearance volume. So the top dead center refers to the topmost position of the piston inside the cylinder, in the cylinder, when the piston is at the top position, beyond which the piston cannot be moved. Similarly, bottom dead center is the lowermost position of the piston in the cylinder, below which the piston cannot be. As the after the completion of the suction process, as the piston is moving from bottom dead center to top dead center, the refrigerant is compressed, where its pressure and temperature is raised. Because the pressure inside is more or than the outside due to the variation in the pressure, the discharge valve, the refrigerant is discharged through the discharge valve, and the next cycle starts. So this is the PV diagram of a reciprocating compressor with clearance volume. Clearance volume is the volume which is provided above the cylinder, above the piston, when the piston is at TDC. Normally, this is provided to avoid direct hitting of the piston with the cylinder head. What happens? Sometimes the refrigerant or the gas which is trapped inside, there are chances of some gases will remain in the clearance volume portion, which might expand later during the suction process. So if you see the process, 4-1 is suction stroke, where the suction valve opens, the refrigerant gas enters. So as the piston moves from TDC to BDC, the volume increases. You can see the volume increases from V4 to V1 until the suction process is completed. Then this is the compression. 1 to 2 is compression. 2 to 3 is discharge. So when the piston is moving, 2 to 3 is discharge. So during that process, the volume decreases. 3 to 4 is expansion process, and 4 to 1 is suction process, and the cycle continues. So if you see, this is the clearance volume. Volume of the cylinder above the piston when the piston is at TDC. And this is the stroke volume or swept volume. That is the volume swept by the piston between TDC and BDC. When we add clearance volume and swept volume, we get total volume. So clearance volume plus swept volume is equal to total volume of the cylinder. So here if you see, Vc refers to V suffix C is nothing but V3, and this is up to this portion, that is Vs plus V. Stroke volume is from V1 minus V3. So when we add swept volume with the clearance volume, we get the total volume. So as I told, it is a piston cylinder arrangement is used. The reciprocating motion of the piston inside the cylinder, the piston reciprocates inside the cylinder, leads to suction and compression process. These are designed for compression ratio 8 to 10. Compression ratio is the ratio of the pressure, that is the discharge pressure to suction pressure. The speed of this type of compressors varies from 300 RPM to 3600 RPM. There are high speed reciprocating compressors, can run up to 3600 RPM. And normally these type of systems are used for cooling capacities up to 125 TR. The efficiency is less compared to screw type and centrifugal due to the various losses. We will be seeing the various losses in the subsequent slide. Now let us make a comparison between ideal and actual reciprocating compressor. So there are primarily 4 major factors which affects the performance of an actual reciprocating compressor. So here I would like to emphasize that in case of an ideal reciprocating compressor, there is no clearance volume. So there is no chance of refrigerant getting trapped in that clearance volume. So the volumetric efficiency is 100% for an ideal condition. But in case of an actual reciprocating compressor, due to these losses, the volumetric efficiency will not be 100%. First one is the clearance volume, which is not there in ideal case. In actual case, since there is some clearance is provided, there are chances of refrigerant getting trapped in that one. So what happens during the next suction process, before the next suction starts, there are chances of this gas or refrigerant getting, there is a re-expansion process. That is this process. 3 to 4. 3 to 4 is expansion process. 1 to 2 is compression. So due to this, there is reduction in the performance of the efficiency of the compressor. And the second factor is the friction. Friction, we know it results in pressure drop. Due to pressure drop, the pressure at the suction valve, it is if it becomes less than the evaporator pressure, what happens? The compression ratio increases. If the compression ratio increases, the discharge pressure increases. The mass flow rate of the refrigerant comes down, due to which the volumetric efficiency reduces. And the volumetric efficiency reduces, the work of compression, that is the power required to drive the compressor, increase. So let me repeat. So the pressure, since the pressure at the suction valve is less than this one, what happens? The compression ratio or the pressure ratio increases, which increases the discharge pressure. The discharge pressure is more, the mass flow rate of the refrigerant circulated, that reduces, which reduces the volumetric efficiency. The reduction in the volumetric efficiency increases the work of compression. Volumetric efficiency is the ratio of actual volume of gas that is taken inside to the compressor displacement rate, or in other words, actual mass flow rate of gas taken inside the compressor to the maximum possible mass flow rate that could be taken inside. Then the third reason is due to heat transfer. The pressure drop takes place across the suction valve and also in the discharge valve, across the valve. And the heat transfer between the refrigerant and the surrounding. So due to this, the suction process, compression and discharge process, it is non-adiabatic. Whereas in case of an ideal condition, it is adiabatic. So here there is a heat transfer between the refrigerant and the surrounding. And of course, leakage is there. Losses due to leakage, that is especially between the cylinder head and the piston. So because of these factors, the efficiency of the actual reciprocating compressor is less compared to the ideal condition. So the next one is the rotary type of compressor. If you see the classification, under positive displacement, we have rotary. In rotary, we have got scroll and screw type. So let us see that one. This is the construction. So here we have, in rotary, of course, there are two types are there: rolling piston and rotating vane. So this is the suction. This is the portion through which the refrigerant enters, and this is the discharge portion. Rotor fixed to an eccentric shaft rotates. There's a rotor which is fixed to the shaft rotates. The vane moves up and down in the slot. And of course, this is the cylinder block, and this is the rotating one. This is the rotating element, or it is called as the vane. So the movement of the rotor and the vane compresses the refrigerant. So small correction is there. It is not just only due to the rotation of the rotor, it is also due to the movement of the rotor as well as the vane that compresses the refrigerant vapor, and it is normally used for very small capacity, up to 5 TR. Let's make a comparison between reciprocating and rotary compressor. Low operational speed and the rotary compressor is high. Discharge pressure is more high in reciprocating compared to rotary. Normally, if you see the size of the reciprocating compressor, it has got a large size. It is not compact, whereas rotary compressor are small in size, which makes them compact. The lubrication is difficult in case of reciprocating compressor, which is quite easy in rotary. Normally, reciprocating compressor are used for small discharge at high pressure, and rotary compressor are used for large discharge at low pressure. And of course, this can be used for cooling capacity up to 125 tons of refrigeration, and whereas rotary is used for a very smaller cooling capacity systems up to 5 TR. So this is a sub-classification of rotary, this one. So as the name indicates, here we have got two, normally these type of compressors are called valveless compressor, this scroll and the other one. True. So we have got two spiral. One spiral is stationary one, and another one is a moving one. So this portion is the suction. This portion is the suction through which the refrigerant enters, and after the refrigerant is compressed, it is discharged through this portion. So it is the compression, only the concept changes. In case of a reciprocating cylinder, it is the piston which compresses the gas inside the cylinder. In case of a rotary, this one we have seen, due to the rotating movement of the rotor as well as the up and down movement of the vane. And in case of a scroll, it is the refrigerant is compressed by the combination of both moving spiral. That is, two spirals are there. One is a fixed spiral, another is a moving spiral. Due to the movement of this spiral, it causes the refrigerant to get compressed. Moving spiral does not rotate, but its center revolves with respect to the center of the fixed vane. When the refrigerant reaches the center position, the discharge pressure is achieved. So if you see this one, the refrigerant is entering like this. So it is going like this. It will go. So as it reaches the center position, okay, so the required discharge pressure is achieved. During operation, continuous suction and discharge takes place. This has got a high volumetric efficiency. It's compact. Noise is low, and the noise level vibration is low much low compared to reciprocating type. Capacity is less sensitive to outdoor conditions. Used for cooling capacity. This is also normally used for smaller cooling capacity. When we compare to reciprocating type, up to 10 tons of refrigeration. This is another type of like valveless rotary compressor, which is the screw compressor. So we have got like screws are there. In the previous one, spiral is used. So here we have got screws. This is the portion through which the refrigerant enters, and it comes out after it is compressed by this screws. By two meshing helical screws are used. If you see make a comparison, like as I said before, piston cylinder in reciprocating, the rotor, the movement of the rotor and the up and down movement of the vane in case of rotary. Of course, scroll and spiral comes under rotary only. In scroll and spiral, more or less the principle is same. The principle is same. Where in scroll, two scrolls are used. In spiral, two helical screws are used. The refrigerant enters at the suction side and move through the thread as these screws rotate. Refrigerant exits at the end of the screws. It is used for cooling capacity between 20 tons of refrigeration and 750 tons of refrigeration. Compression ratio of about 20 to 25 is possible. And it handles large amount of refrigerant flow rate, available for wide range of refrigerant and applications. No vibration problem. Very small power is required. So these are some of the salient features. Self-explanatory. Loss due to friction is less. Applicable to refrigerants that have high condensing pressures. So let me conclude this lecture with this one. Thank you.